True or false? If x and y are non-zero vectors, then the dot product of x with y is equal to 0 if and only if x and y are perpendicular, or when we're dealing with vectors we call them orthogonal. It's an if and only if, which means we need to show that first, if x and y are perpendicular, that x transpose y is equal to 0. I'll put an arrow this way, which means if we assume that they're orthogonal, then we would need to show that x transpose y is equal to 0, but I think we already did that. That was problem number 1.4.4.5, so that way works. It is true that the implication works one way by 1.4.4.5 homework problem. The other way, we would need to show that if the dot product is 0, then x and y are perpendicular or orthogonal. Well, let's see. The last problem we did tells us something about the angle between the two vectors. It has to be the dot product divided by the length of x times the length of y. And in this particular case, we would know that the cosine of theta, which is the dot product of x with y divided by the length of x and also divided by the length of y, must be 0 if the dot product is equal to 0. But if the dot product is equal to 0, the cosine of theta has to be 0. So that would mean theta must be 90 degrees. So x and y must be perpendicular, or what we call orthogonal. Notice also we say that all vectors are orthogonal to the 0 vector. So we didn't even need to be sure that we were dealing with non-zero vectors here. The only reason we included that was because in this particular case, if we were trying to use the last lemma, or the last homework, which was 1.4.4.6, we needed to make sure we were not dividing by 0. But in general, if the dot product of two vectors is 0, the vectors are orthogonal.